Okay, notice 2-4, we're going to be doing more of solving log and exponential equations. When solving log equations, the key is to solve it by making your log disappear. Okay, so there's two different ways of doing that. So if you're given an all log equation, you're trying to condense both sides. It says get both sides in terms of log of b. Okay, so once you have condensed both sides to one log, then you're just setting m equal to n. Okay, so that's all logs. Alright, if you have some logs, so some log terms and some that are not log terms, you're going to rewrite as an exponential equation. So you're using around the world. Okay, so we'll make sure that you condense to one log, if it's not already in that form. Once it's one log equals a non-log, then you can use around the world to solve it. Okay, so those are the types we're going to look at in the front. So it says solve each of the following by using one of the methods listed above. You may first have to use the laws of logs to combine some terms, which means condense. Okay? Alright, so first we have to determine if it's all or some. So notice we have a log, and a log. So this would be all. So what we're trying to do is condense the left side into one log, which it's already in that form. Condense the right side, which we need to do. So I'm just going to rewrite the left side. Condensing the right side, I need to make the coefficient an exponent. And then when we're adding two logs that have the same base, we multiply them. So log base A, we have 3 squared times 5. You need to work that out. So 3 squared is 9 times 5 would give you 45. So log base A of 45. If you have all logs, condense the left side, condense the right side. Once you have it in that form, those two logs are equal, which means you can just drop those and set those equals. So x equals 45. There's your answer. So all logs, condense the left, condense the right side, then you're just dropping the logs and setting that m equal to n. Make sure that you just plug it back in, it gives you a positive there. Okay, so looking at number 2, so we have a log term, and then a non-log term that doesn't have an log with it. Okay, so this is sum. So we want to condense, then use around the world. So we're going to condense the left side. We're adding those two, so to condense we'll multiply log base 3 of x times x minus 6. So I'm going to go ahead and, you can go ahead and multiply it or go ahead and do around the world. So my base is 3 to the third power equals x. I'm going to go ahead and multiply it, x squared minus 6x. Okay, so 3 squared we get 27 equals x squared minus 6x. So notice now we have a quadratic equation. To solve it, I'm going to set it equal to 0 and I'm going to factor it. So I'm going to subtract 27 because notice my x squared term is positive and that's what I want. So 0 equals x squared minus 6x minus 27. Okay, so we have 3 terms. The sum is -6, product is -27. So that would be -9 and 3. Once we have factored, to solve the equation, you're setting each one equal to 0. So x would equal 9. And x would equal -3. Make sure that you plug it back into the original. Notice 9 would give us a positive there, but if we plugged in a -3 here, that's going to give us a negative for that m there. We can't have that. So the only answer would be x equals 9. Okay, so let's look at the back. Now we're going to look at some exponential equations. on exponential equations, you're wanting to isolate the base with the exponent, then take the log of both sides. Now, something that we haven't looked at, if you have x's on both sides and you have a base on both sides, try writing both sides of the equation as the powers of the same base. Okay? It makes it easier to solve, and we'll look at that in just a second. It says if the variable is the base, so if x is your base instead of part of your exponent, then you're just raising it to the reciprocal power. We've already gone over that with rational exponents. Okay, so we're going to solve each of the following using one of the methods listed above. Okay, so first off, we have 4 to the x equals 50. We're trying to figure out 4 raised to what power gives us 50. Okay, so notice my base and exponent is already isolated. So I'm going to go ahead and take the log of both sides. Whatever I do to one side, I have to do to the other. So make sure if you take the log of one side, you have to take the log of the other side. The reason I'm taking the log is so that way that exponent I can bring in front. So the x log of 4 equals log of 50. From here, we're wanting to get x by itself to solve, so I'm going to divide by log of 4. And then I'm using the calculator. So I'm taking the common log, which is to the left of number 7, of 50, divided by common log of 4. Let's run the 3 decimal places, 2.822. If you wanted to check it, plug it back in, 4 raised to that power, which is second negative, and then notice it gives you 50. So you can check that. Okay, let's look at 4. So remember, your first step is to isolate the base with the exponent. So this is my base, 4 to the 2 minus x power. That is not by itself. We have a divided by 3 there. So the first step, we have to isolate it. So the first step is to multiply both sides by 3 and get rid of that denominator there. So I have 4 to the 2 minus x power equals 21. Now I have my base with my exponent by itself. So now I'm going to take the log of both sides, and I'm going to go ahead and skip that step and bring this in front. So 2 minus x in front, then log of 4 equals log of 21. So notice we don't have variables on both sides. So now all we need to do is get rid of that log term. So I'm dividing by log of 4. So we have 2 minus x equals log of 21 divided by log of 4. Let's run it 3 decimal places, 2.196. And then from here, we're getting x by itself. X isn't by itself, so we have to do a couple more steps. Come on, calculator. All right. So we need to subtract 2. So we get negative x equals, when I subtract 2 from that, I get 0.196. And then to get rid of the negative, I divide by negative 1. So we should get x equals a negative 0.196. And then you can plug it back in and check it. Okay, so notice on 5, we have variables on both sides. If you have variables on both sides, before you take the log of both sides, you need to look and see if you can rewrite that highest base as the same base as the smaller base. So notice the higher base is 64 here. I want it to match this base, which is a base of 4. I can rewrite 64 with a base of 4. So 4 to what power will give me 64? 4 squared is 16. 4 cubed is 64. So I'm going to rewrite the left side. And then I'm going to rewrite the right side. Instead of writing 64 there, I'm going to do 4 cubed, which still gives me 64. So that's the same thing. But then I have to multiply it by that exponent that's already there. And actually, I'm going to write it like this. So 4 cubed is the same thing as 64. And so I'm just rewriting it. So I have 4 to the x minus 2 power. I have to multiply those together, so that would be 4 to the 3x power. Now the reason I did that is because now notice that these bases are equal. If the bases are equal and this is an equation, we know that their exponents have to also be equal. So it makes it easier for us to solve. I'm just going to set x minus 2 equal to 3x. So now I just have a linear equation. So I'm going to subtract x. And I have a negative 2 equals 2x. So x would equal negative 1. So if you did not notice that you could rewrite 64 to have a base of 4, which is 4 cubed, then you would have had to take the log of both sides, add your x's to one side, then factor out the x like we did on the last lesson. Okay, so you can still, if you don't like doing that, you can still take the log of both sides, move your x's to one side, and then solve for x. Okay, but it makes it easier if you have variables on both sides. See if you can match those bases, because if the bases match, then we know the exponents have to also match, which is they're equal. Okay. All right. So then notice in this last one, we actually don't have an exponential equation, so because our base is x. So this one we went over with rational exponents. We need to raise this. I'm just going to rewrite this. We need to raise this to the reciprocal power, which would be 4/3. So those cancel, and we just have x. And then remember, when we are dealing with rational exponents, the bottom is your index, the top is your exponent. So we're going to work this out. So I'm taking the cube root of 8, and then I'm raising it to the 4th power. So you should know the cube root of 8 is 2, and then we need to raise that to the 4th power. So 2 times 2, we get 4, times 2, we get 8, times 2, we get 16. So x equals 16. So if your base is the x, then you're just raising it to that reciprocal power to get rid of that exponent. Okay, so if you have any questions on solving equations with logs or without logs, make sure that you're coming in to get help.